Ready?
Yep.
All right. So again, we just did this chapter. So it's actually going to be probably fresh in your brain a little bit, hopefully. Okay, so what is a rational function? This is what you just took a test on. A lot of you did very well on this last test. What is a rational function? Remember, that's a ratio, right? If you have something like x over 5x, that's going to be a ratio. So I'm just going to put ratio. And I'm going to put two things on there because your final exam asks you, and that pink packet, which one of these is not rational? And that was a question that was on your last test as well. So I'm going to put not rational, and I'm going to give you two conditions that are going to occur if it's not rational. The first condition, so condition 1, would be that little radical symbol. If you see a radical at all, it's not rational. That's called a radical function. Okay. If the second condition is if you have a variable in the exponent, so something like 5 to the x power. And I'll write that out like variable in the exponent. Those are the two conditions that would make a function not rational. Those are the only two. Right? Everything else is rational. Everything. Technically, a quadratic function is rational. Technically, a polynomial function is rational. Okay? All right. So speaking of those two conditions, the next question says, looking at these, label if it is rational or not rational. So first, look at the first one. Does this one right here, f of x, have any of those not conditions? Yes or no?
Yes.
No. Yes.
Yes, they do.
I don't know.
Yes.
I didn't hear what you asked.
Yes.
So let's go back really quick.
Yes, it does.
Hold on.
There's an exponent.
Is there a variable in the exponent?
No.
No. So this one is rational. So this one is rational.
So, I don't know.
Okay, here's why. Because it doesn't have a radical. It doesn't have a variable in the exponent. Variable is just a letter. Do you see how?
Variable would be an
What's it saying?
variable would be an x.
Yeah, or a y or any letter. Okay, this one, does q of x have any of these conditions?
Yes.
Yes, it has a square root sign. So this one is not rational. So if that was if that was a question on your final, you would circle q of x. It's going to say which one is not rational, and you would circle this one because it says not. You can't have a square root in a rational function. The next one says, for any rational functions, state the discontinuities. You guys were really good at this across the board. You guys did well on your last test on this one. Discontinuities is what makes the bottom equal to 0. Give you a second to write that, and then we'll talk about the one above. So because this one was rational, I'm going to come down here and talk about this one. I'm literally just going to rewrite it so that you guys don't get confused when you look back. Plus 2x over x plus 5. I'm just rewriting it. I didn't do any math. I just rewrote. What makes the denominator equal to 0? What can't x be? -5. Very good. So x cannot be -5 is my final answer there. You guys were really good at that one. Okay. Questions? Remember that? It was right like maybe a week or two ago. Hopefully a little bit.
Is it always going to be changed to sign?
Anything that is a factor. So this is a factor, x plus 5. So you would have to switch the signs to find it 0. Yes. Okay. So just like yesterday, how when we had this and we asked for the 0, your 0 would be -5. So anytime it's in parentheses or in a group, it would always be the opposite. Yes. That's a good question. Okay. Speaking of that, where does the removable discontinuity, which is a whole, occur? Remember, that happens when something cancels. And what makes that 6, though? What makes that?
On top.
You're right. So this would be a whole. So I'm going to cross this out, and I'm going to write whole. And where is the whole located at? X equals Very good, 6. Remember, you switched the sign, and that's it. So you would have a hole in this graph at the x value of 6. So if you were to go on your graph at x equals 6, you would have this hole there. Okay? Okay? That's the only one that has a hole. That 4 is technically your x-intercept if you really wanted to know. Well, we got 2 more after that, actually. Okay, we got to go back a little bit. Yep. Domain. Okay, the domain. You have to look at your vertical asymptotes, 1 or 2. Okay, so this guy, what can't x be? 5. Okay, so let's talk about that. On your review, the pink packet, and on the final. Before, this is what we used to write out. You don't have to write out unless you want to. Negative infinity to 5, 5 to infinity. I think you all remember doing that. However, on the test, it's going to say this. All real numbers except 5. Because really that's what you're saying. Okay, so or all real numbers except 5 is what the format of your final will look like. Okay? All real numbers except the number 5. That means that every single number on the planet works out but 5. And that's what you just said right here. X can't be 5. That's all. When you are done copying that down, flip back like a page or two, and we crossed off number 4. It has like this little right here. That's where we're going to go. We have 2 more left. That's it. I'll show you right now. Looks like this. And we are going to cross this one out because I told you that the packet was copied weird yesterday. Okay, so we're going to cross that one out. We did number 4 already. Remember when Mason asked that awesome question on chapter 5? Yeah. Okay, so that one was way more relatable to number 4 than this one is. So I wanted to make sure that you just use that one and not this one. Okay, so I'm going to go right down to number 5. It asks, identify the vertical and horizontal asymptotes. There's 2 questions there. So remember, vertical is x equals something, and horizontal is y equals something. Okay? Let's talk about each piece. The vertical asymptote is what makes the bottom equal to 0. Whereas the horizontal asymptote, if you remember from back a week or 2 ago, I'll put a little star here. The horizontal asymptote is those 3 rules. 3 rules. And if you look up here, I added something to the board. Okay? I'm going to put it back down. But this right here, take a picture before you leave on Friday. It will be erased. Okay? So that is a great thing to have. It'll answer 2 of your questions on the final right there. Okay? So again, those are your 3 rules. If the degree is higher on the top, there was no horizontal asymptote. If the degree is higher on the bottom, y equals 0 was the horizontal asymptote. If they're the same, you got to do the ratio. Okay, so let's talk about this. I'm going to put 1 and 2. That way you know which one I'm talking about when you look back at your notes. So number 1, what are the vertical asymptotes? Well, relax. Your vertical asymptote is x equals what number? -1. What about this guy? 2. Very good. These are your vertical asymptotes. Number 2, asks you for the horizontal asymptote. What is the degree of the top? Are there any x's up there? No. So the degree is 0 on the top. What is the degree on the bottom? 2. Good, because there's 2 x's. Well, the 3 rules say, if the degree is higher on the bottom, do you remember what our horizontal asymptote is? Y equals what? Very good. Y equals 0 is your horizontal asymptote. And you're done. It will be important that you have those 3 rules so that you can remember that. Put them in a good location on your yellow sheet so that you can refer to it whenever you need to. I think there's 2 questions that are on the final that are like that. This one and the next one. We got one more. Got one more. Could do it. Yeah.
Don't worry. We have one.
Given the function, identify the end behavior. End behavior for rational, we talked about end behavior yesterday and the day before, but rational is a little different. End behavior, you have to look at your horizontal asymptote. Look at your horizontal asymptote. Now, you can look at it from your graph, or you can look at it from your 3 rules. So on the graph, we'll come back to the graph actually. Okay, so let's take a look. What is the degree of the top here? 1. What about the bottom? 2. Which one's larger? The bottom. And that automatically tells me y equals what is my horizontal asymptote? 0. That's your answer to these problems. And I'll scroll down in a second once you have that written down. I'll explain it. I still need like 3 more minutes from you guys. Okay, take a look here. On your graph, do you see how the ends of your graph right here and right here, the graph is going to y equals 0. You didn't have to do that if you didn't want to. If you can look at the graph and see that this arrow is pointing at the number y equals 0, you're good to go. Because your final answer, the ends are going to 0. Now, before you finish their packet, okay, I might have missed some numbers, I don't know, but just know you have to finish your packet, okay? Again, the pink packet is your final. I am telling you that, I'm not lying. If you want to do on the final, you have to understand the pink packet. Okay, there's no ifs, ands, or buts. I'm not going to throw some random questions at you, I promise. Okay.